Greetings. Let us understand the power of compounding and wealth creation through regular savings. So here we just take a small example in which we have in column A time period and in column B just a simple value of money as it grows through the periods. Now at time t equals let's just say we start with period one and then keep on adding one period to it. And we do so through the period 480, which is which is oh, did we copy? We didn't copy it. Control C, and then let's go to the cell 481 and paste it. So we have 480 periods, and we will say the payment that we are trying to save is $100. And let's assume we have a match from our company. So I'm going to insert a row, one row above, and say it's time t equals 0. So actually, we'll not insert a row, we'll remove it. We'll say we start from time t equals 1 with $100. So equals 100. And then equals, so let's assume that we have a rate times parenthesis 1 plus rate divided by 12. It's an annual rate, and we're doing monthly investment here. It's because 480 months. So this is how the value will grow every month. But remember, we also are inputting new amount. So we have to add the $100. So the previous amount is growing at the rate of 4%, let's say it's money market fund. And the previous principal is also being added to this value. So we had the 100 that grew to 103.33. On top of that, we added a new $100. And we keep doing this for 480 periods. So now we will see that the rate constantly change. So we have to fix the cell D3 and then we can paste it. There we go. So we have seen small changes. So it becomes 301, 402, 503, and so on. And so at the end of the 480th period, we have $118,000. Now let's assume that we have a company match. So instead of this, we have this times 2. So we save this in our retirement amount account, and the company is matching it dollar to dollar. So not only is the previous amount growing, but we're also getting matched. So we're getting D2 times 2. And so with this, the amount will double, should double. So 236.392. So this is how much we'll end up with just $100 per month for 40 years. Now let's assume the rate goes up to 5%. So the 200 becomes 300, 6%, $400,000. So I'm concentrating on this cell here in particular. So this becomes 400,000. At 7% becomes $500,000 for just $100 a month. And at 8%, $700,000, $1,000. And at stock market rate, which is approximately 11.5, there are contradictions and disputes about it, but approximately 11.5 or 12% becomes $2 million. So we can actually search S&P 500 returns last 30 years. And the AI answer is about 11%, including dividends. So that's a valid assumption. So 11%. So we have $1.7 billion. Now, we can actually create a chart of this. So let's make a chart of this time and value. So you can see how initially it might not seem to be growing much. For the first 100 months, it's not even achieved 100,000 probably. Let's see. First 100 months, it's not even achieved 100,000, just 35,000. So it might seem depressing, but when it starts reaching the critical mass, so approximately somewhere here, 400,000 to $500,000, then it really starts to blow up. And so that's the power of compounding. So this is chart one. Now we can do a comparative analysis here, and we can do a rate versus amount calculations. So in Google Sheets, there is a very simple way in which we can do this. So 4% equals this plus 0.01, and I can go on to 11%. So all we do is use the future value formula, rate divided by 12, number of periods, let's put it here. Um, Payment amount, let's put it here. Oh, actually, minus I4, present value is 0, and big end of the period consideration. So this is, we have to add number of periods and the payment amount. So number of periods is 480, and the payment amount is 100, just $100. So this is enter and payment, and then we just say equals this and just paste it down. Okay, and then just copy the formula down. As you can see, as the rate increases, the amount reaches the final value very fast. Now, this is just $100. It's not even $200. It does not include the company match. So we have to make sure that the company match is factored in. 236, 305, 400, 500, 700, million point seven in 480 periods. So somebody might be curious, what if I just invest for 360 periods? So you won't get that kind of appreciation, only 560. So the last 120 months, last 10 years is extremely important. Every year matters towards, especially towards the end when the capital is large, really blows up. So that's an important consideration. So now, if we say 360 periods and let's say it's reasonable to assume $400 investment, it becomes $2.2 million. Dollars. Or $400 a month with a company match, 480 periods becomes nearly $7 million dollars at 11%. And at 12%, slightly above the market return, we should get $9.4 million. Dollars. So that is the power of compounding and discipline and just saving at a steady pace for an extended period of time. So you can see that 10 million is just crazy. The last piece is NVIDIA stock in the 2026 period. So we looked at return from NVIDIA stock in 2020, 2021, 2022, 2023, and 2024, and 2025. So if we had invested in NVIDIA stock, so the year 2020, at the end of 2019, for example, and NVIDIA is just a special case, obviously, but you can see the power of compounding in an extreme way in this study. So we'll first find out the average rate of return from the NVIDIA stock. In 2020, NVIDIA stock gave us a return of 122%, 122%, meaning that $1 invested in at the end of 2019 would have given us $2.22. And so we're going to use this formula and replicate it further. Just let's put the numbers up. So 125% minus 50%. So lost half the value. 239%. So generally speaking, a very good year comes after a very bad year. 171%. And as of 2025, it had given about 55% appreciation. So all we say is that $1 would have become $36, or let's just say a small simple investment of $2,000 or $500. would have become $17,800 in by the end of 2025, so in about 6 years. And if we apply this value in this graph of our simple savings, it would have gone crazy. So this, if I applied even one of these values, 150%, the 9 million would become 22 million, $22 billion. So that's how it's, an explosive thing. So that is the power of compounding and regular payments with the help of compound interest, especially in retirement savings like IRAs or 401ks. Thank you for listening.